Okay, section 5.2, characteristics of polynomial functions. Here we have a function f of x is equal to negative 5x minus 2. The first thing we're asked to determine is the degree of the function. Now, we know that all lines have a degree of 1. All linear functions have a degree of 1. So we can write that in there. But by looking, if we didn't have our graph, we were just looking at our equation, we're looking for the variable with the highest degree. Now, there's only one variable here, and it doesn't have an exponent. And if it doesn't have an exponent, that means that its exponent is a 1. So the degree of the function is equal to the highest exponent, which in this case is 1. Now the number of x-intercepts, as you can see, this line is going to cross the x-axis once. So the number of x-intercepts for any linear function is going to be 1. The y-intercept, it might be a little bit difficult to see, but it's crossing here at y equals negative 2, or we could say 0.0, negative 2. Now, something you might notice is that this is the same value as our constant term. So if we're looking up here at our constant term is negative 2, that is the same value as our y when it crosses the y-axis. So we actually can determine our y-intercept by looking at the constant from our equation or from our function. Now the end behavior. We have to look at our leading coefficient. Our leading coefficient is the coefficient that's attached to the variable with the highest degree. Now we only have one variable here, so our leading coefficient must be negative 5. Now because our leading coefficient is negative 5, we know that the function slopes down to the right. So we know it should start in quadrant 2, and it should extend downwards to the right into quadrant 4. And if you're not sure, if you don't remember your quadrants, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Now, domain and range are a bit trickier. As you're looking at this value, you notice that the line doesn't end. It's just cut off where we took a snapshot of our window, but this line would extend on forever. Now it's extending outwards to the left and it's extending outwards to the right, which means my x values are going to continue getting smaller as I move to the left, and they're going to continue getting bigger as I move to the right. So what we would say here is that when we're talking about our x values, x can be an element of the real. It can be any real number. It's just going to keep getting bigger and smaller as we extend outwards to the left and the right. Now when we're talking about our range, we're talking about our y values. Again, as we're looking at this, we can see that it's extending upwards and it's extending downwards. As it extends upwards, its y values are going to continue getting bigger and bigger. As it extends downwards, its y values are going to continue getting smaller and smaller. So that means that we can have any y value. So we would say that y is an element of the real numbers because y is just going to continue getting bigger and smaller as we extend upwards and downwards. Now the number of turning points is just the number of times the graph changes directions. Now if you look at this graph, the function doesn't change directions at all. It's one straight line. So we would say that it has 0 turning points.